So hopefully you took some time to be able to work this problem out. One of the best ways to try to work with radian measures that aren't necessarily on the unit circle is to convert them to degrees. To convert to degrees, remember you use the conversion factor. So this is going to be pi and 180. So I'm going to multiply this by 180 divided by pi. Okay. Now notice what happens, and this is to convert to the degrees. So I'm going to say 180 degrees for every 1/2 revolution of the circle, or pi radians. The pi's cancel out. We know that 180 divided by 4 is going to be 45. So, and unfortunately I don't have my calculator with me, so I know that I'm going to take 45, multiply by 13, so this gives me 135 and 45, so I end up with 585 degrees. That's going to be negative. So negative 13 pi fourths is negative 585 degrees. Okay. Now, remember what we said is that if it's not on a unit circle, what we do is we just add 360. So let's just add 360 to this guy, or subtract 360, but I think adding 360 is going to get us to our answer a little bit quicker. Okay. If I add this, this gives me negative 215 degrees. Oh, 225, excuse me. It'd be helpful if I could subtract. And unfortunately, negative 225 is not on the unit circle, so I'm going to add another 360 degrees to this. Okay? And what we end up with is a positive 135 degrees. Okay? So the good news is that we go through, we just convert the degree measure, okay? And then we can just use the coterminal. Now you guys can do it a lot quicker than I did because you're going to have a graphing calculator or any calculator available. And all you're going to do is just find what happens at 135 degrees. Okay? So on your unit circle, here's our unit circle, 135 is going to end up in quadrant number 2. Okay? So again, you just go on your unit circle and you're going to go to 135 degrees. And at 135, you can see, so if we end up at 135 degrees, we know that we get a negative root 2 over 2 and root 2 over 2 as our x and y coordinates. From here, the rest of it should be fairly easy. We know that the cosine of negative 13 pi fourths is going to end up being the x coordinate, negative root 2 over 2. And then the sine of negative 13 pi fourths is the y coordinate, which is a positive root 2 over 2. And then, if I want the tangent of negative 13 pi fourths, we just take the y coordinate divided by the x coordinate, so we get root 2 over 2 divided by negative root 2 over 2, okay? Which ends up just being a negative 1. The rest of them, we just find the reciprocals and we're done. Right? So we end up with the cosecant of negative 13 pi fourths is negative 2 over root 2. If we were to rationalize it, we end up with a negative root 2. After just a little bit of rationalization, go ahead and check to make sure you can do that for yourself. Obviously, if the sine is root 2 over 2, we flip it over and get 2 root 2, and then we go ahead and rationalize it. It's going to be the same value, except it's going to be positive. So we get 2 over root 2, otherwise known as positive root 2. And then finally, the easiest one, the reciprocal of negative 1 is still negative 1. So cotangent of negative 13 pi fourths is negative 1. All right. So hopefully with these 3 examples, if you weren't good with trigonometry before, now you guys are good at evaluating the trig functions. And you have to be good at least at that and being able to figure out the rest of the triangle from there, okay? Now, in the last set of videos that we're going to do with the equations, we're going to go backwards. And we're going to find the angles if we're given the values, okay? But we'll worry about that in a few moments when we get to it.